Hello friends, welcome back to this AI mindset related playlist, and today we are going to start a new series called as RAG, Retrieval Augmented Generation. So let's get started. So in this entire series, the first video is all about the data collection strategies. So we can know more about RAG and other things in further videos, but the first step in the RAG, which is retrieval augmented generation, is basically the data source. So we are going to collect the data. Majorly there are only 3 to 4 types of data sources, let's say PDF or database or something, but then we are going to take a retrospective view on what are the different types of data which we can bring into our ecosystem and then process it. So 17 powerful data collection strategies which you might be ignoring. So let's get started. By the way, this entire source code is available here, uh, and the link is in the description. So we will see different types of data, how we can process and what we can do on the data. Okay, so let's get started. Right. So we'll start with the data collection, step one, and also the demo part. Right. So for the first thing, I would like to go for database. So database is normally one of those very good source of information, and it is mostly the RDBMS relational database, and from that we can extract some data. So I have this Docker running and I have a Postgres running on my local, and there are only two tables. So let's say I have done an e-commerce setup where I have, let's say, a product detail page. So in that I have a categories and products databases, and there are different there's a different content in it. Okay, so there is around 200 lines of content in the uh, products, and in the categories there are, let's say, four categories. So this is one setup, and then what we need to do, that we need to extract a meaningful data. So for to extract meaningful data, we need to know what are the tables inside this particular database. Of course we can give the uh, table name and column name, but then at the same time we can pass on some additional information about the table, about their schema and other things while generating or while creating the table. So that will help the basically the further model which we are going to see, the LLM part, we to design the query or optimize SQL query and so on. So basically connecting to a database and then running some queries at the nutshell, right? So yeah, before that, there are a lot of requirements, packages we need to install, around 45 packages for the entire data collection suite. So we'll have to do it. And also I'm using Python 3.11. Okay, 3.11 I'm using just to be on the safer side. uh, but we can use higher version, but then yes, I'm using the little older version. Right, so Postgres SQL. Yeah, so I'm using database name, user and password, and then host, which is on localhost. So I have designed some functions which will methods which will raise a database query, something which will extract the schema for different tables, and maybe we can clean some table. So we'll see what are the activities we can do. So when we do database processing, of course the SQL queries and all has to be designed while developing the particular module. But then schema aware uh, metadata extraction is the process of retrieving structural and descriptive information about a database, such as table names, column data types, primary and foreign keys, and natural language description to provide semantic context to LLM. This is important, semantic context to LLM, because in future LLM may automatically generate a query for a particular customer need and then get the data. So for that it needs some certain information about the table which will come from the description of the table, right? So right, so this is one method which will basically extract the schema from the table, from the database, and then here there is a query which is this, select table name, column name, data type, and then the description information of the table, and so on. So while creating a table, let me just show one script. While creating a table, okay, we can add some kind of additional information. So when I generate the table, this SQL query, right? So in the SQL query, I am passing the comment on the table. So for example, it's a categories table, products table, and I'm passing additional information about primary key, display name, URL friendly, and so on. So if we pass more and more relevant info for a particular column, particular table, then we can just extract this with the help of this SQL query, and then the LLM will be able to fine tune the queries. Okay, right. So when we run this query, we can extract the schema, and then that will we can feed to LLM for further operation. Now this is about the extracting schema, and then let's say there is some garbage data or dirty data, for example, and this is just an example. If you see the categories table, if you products table, so if you see the product item description, image URL, and so on. So there is something which we can do now. Garbage, insert 10 garbage categories. So again, this is an automated generated query. So where what I can say is, instead of category, let's say category shoes, category table, category laptop, I will say category hyphen some random number. So this is not a real world information, this is not a real world uh, naming convention. So when we introduce this kind of garbage, uh, basically, so how do we clear it out? So that we can do using some kind of a uh, uh, regex. Okay, again, this is a very specific example which may not be related to the actual real life example, but I'm just considering one example here. Okay, and then I can simply run a query. Okay, select star from something where the price is between some range, and so on. So the point here is, on a database, we can do different operations. We can extract the schema and then clean the product data, and then probably raise some query, and so on. So this is a starter point, that okay, on a database we can do a lot of things, right? So let's just run it. Okay, so first thing is table categories. So there are certain information available here in the products table. There is certain information available. This is certainly going to be more detailed information when we feed it to LLM for automatically uh, designing queries. Okay, then again some product description. So here I am doing a cleanup. So second thing is I'm doing a cleanup. So I'm giving it a pattern, that okay, if you see this kind of pattern, just ignore this and uh, clean the data. So this particular things are cleared. Then I'm fetching some data from the SQL from the categories, from the products table. So that is why I've received some information. Okay, right. So moving on. So first thing is, we will interface. We'll have discussion for our interface for the database. Second, next thing is the email. Okay, so we might have to extract some information from email. Normally we have .eml file or .msg file. Let it be a Gmail, Google email, or your Microsoft Outlook, or so on. So .email file and .msg file. So what we can do on those particular file, again, this is not that much information, that much important, but then this is one of the source of information, so we can extract it. So if it is a .email file, we can extract the metadata header, we can extract the body, and we can say the attachment. Same thing for MSG file, so we can extract the metadata, email body, and we can also extract and save the attachments, let's say image or PDF separately. So I have the sample data, which is emails. So I have this .eml and .msg file and some other email file, and then this is one folder created where I have I have some images, some files. So let me just take it out. Yeah. So now how to extract this and how to process this and how to save the attachment. So we have certain libraries for that. So we have an inbuilt library email, and we have library called as extract msg, and so on. So .email and the attachments folder. So parse the .email file, okay, and then extract. Basically this is on variable msg, where it will return the subject or from and to and date and so on. Okay, now from that .email file we can extract the body. So msg.get body in the plain format, get content, and then we can just from the content we can print the, let's say, first 100 characters and so on. And we can also save the attachments like this. Okay, like this. Now next is the msg file. So we'll see the msg file in a bit. We will see the .email file. So .email file is this one. Okay, so let's just run it. Okay, so it saved one pdf, so which was an attachment called a small pdf.pdf. So yeah, small pdf.pdf. So this was an attachment in the original email, right? Okay, let me just delete it for now and go back to this, and then we will see the email content. So if you see from, to, date, body, there's an attachment sent with this email, whatever domain name and attachment. Yeah, so we're able to extract a lot of things. Okay, same thing we will do for the .msg file. Okay, so .msg file is this one, and it will we can save again the same content and everything in this particular folder. So let me just once delete this folder, so it will be created dynamically, and run this. Right, so yeah, there's a big content again, subject, from, to, date, all header part, plain text, and again thing, the body, sent from, and then this is a mail chain basically. So one email reply to other reply to this, and then this again replied. So there's a two back and forth, so everything is captured here, and it has two attachments. One is one pdf and one is bmp file. So let's see, in this folder we have a bmp file which was an attachment, and same small pdf.pdf. Okay, right. So this is how this, we can dig more into the email body part and so on, but then for now it's sufficient to do this much. Okay, right, now moving on. So video file, this is a bit tricky, because normally uh, we mostly process the text part. Probably sometimes we'll process the image, but then this is a video. So if there are some projects of LLM where we want to find out some objects in the video or take some action, so in that, video analytics is important, and then we can extract something from the video. So basically one thing is we can detect the object from a video. This library YOLO, which has lot of pre-trained databases, where pre-trained models, where it can identify whether the object is a person or a, different, there are like maybe 100 200 types of objects where it can easily identify. Now this library has so I'll show this video first. So we have a video. Okay, so this is a video. There are some people walking, and there is, it's a street view or something, right? So what this library will do is it will identify whether there are, what are the objects in the video. Okay, now sometimes this is resource heavy, so this may not work sometimes, but let's see. Right, so this is a sample code. Again, it is available on the GitHub. So let's play. So what it will do, it will detect the object, and it will show the boundary of that object, and with the confidence level, like, okay, it is 100% a person or a vehicle or a whatever. So you see, there you go. So there's a person, there's a person holding bicycle, car. Awesome. Again, the confidence level 92%, 90.91%, 90% car, bicycle 40%, so on. So this way we can print this as a text also in the console, and then we can identify, okay, there are, let's say, 10 persons or two cars in a particular view. Okay, yeah, yes. So three bicycles, three cars, 15 persons, two bicycle, three cars. So for now it is person, bicycle and cars, but it might be other things also based on the video. Again, it will try to identify, let's say, the mostly used 100 200 objects, but there can be different objects. So in the RAG we can have this as a data input, and we can process. Okay, right. Now moving on. So about the audio part. Okay, so we are done with the audio, we're done with video. So database, email, video, audio. Yeah, so we'll start with the audio. So in the audio, there are some projects where audio is processed and given to LLM. So audio generation and synthesis. So user use generative AI models to create entirely new music or synthesize human-like speech, like text to speech, speech, audio to text. Simple, we can do text to speech. We have a GTTS library, and then we can also do with Whisper, which is a simple speech to text. Okay, to text to speech, speech to text, and so on. Again, this is not that much heavy, but yes, we can do. We can process audio files also, and we can extract the text. Now, normally it is in English, but we can also use different languages. For example, let's say French, Japanese, Chinese, and whatever. There are many languages are supported. So that kind of text, that kind of speech to text can also be identified. And once we have that text, let's say in French or in Chinese, we can convert that into uh, English also, and then and then the LLM will process and so on. Okay, so I have this audio. Okay, so this audio will be extracted and then speech to text. So text to speech is not that great, but we will just do like this, uh, and then speech to text. So let's run it. And this is the speech to text. Kids are talking by the door, right? So we can do many other operations, but these are the top two things we can do on audio. Now coming to image. So image has a lot of other things and many things. So image processing. So let me just close this other stuff. Okay, right. So image. So apart from simply converting to BMP to PNG to JPG, those kind of thing. So what we can do is we can use simple, easy to use level, let's say deep face, and so on, where we can do facial recognition and emotion detection. So detect human faces and verify identities or analyze face landmarks to predict emotions. Okay, like for example, happy, sad, surprise. So there are different libraries. So we'll go for deep face, which is simple and easy to work with, and then facial recognition. So who is this person again. We cannot identify each and every person, but then let's say, so there are top 2000 popular people in politics, in uh, movies, or in some other field, so which we can identify. We can generate some data set, and then we can match it with the current image, and so on. So basically, face recognition, face landmarks are identified, and face encoding. So the image is converted into a vector of numbers, usually 128 or 256 measurements, and so on. So there is some algo. Okay, so let's see one example. So there is one image of Obama, which is the original image, and the face is smiling, and this is another person which is similar to the first person, but different, not exactly the same. And also the facial recognition says it is not in a good mood. Okay, so facial recognition, so we can say that is it the same person, so we can identify whether they are the same or different, and with a confidence percentage. Okay, so basically going to match these two images and give us the result. Okay, is it the same person? False. Okay, because it is not exactly the same. Okay, so let's see the image, and let's see this one first. Okay, so though those both are looking same, but they are not same. Okay, so if you observe carefully, those are two people which are not same, right? So that is why we got the output for same person false. Okay, now emotion detection. So this process answers the question, how is the person feeling? Okay, so again, landmark analysis and classification. So uh, for example, raised eyebrows, surprised. Pulled back lip corners is happy. Okay, and maybe pulled down lip covers, it is unhappy or sad. Okay, so like this, there are some standard practices followed, and then probably let's say 80 to 90% of the time we can identify. So dominant emotion is happy in the first image. Okay, confidence is 100%. That's good, because the first person, if you see, this is the it is happy person. Okay, and second person, so this one looks sad. Okay, because the lips are down, right? So that is why it is 88% fear emotion. Okay, and so on. So like this we can do a lot of other operations on this on images. For example, angry, fear, neutral, sad, disgust, happy, and surprise. Future scope is create entirely new images from the text prompt and modify the existing ones. For example, if the person is looking happy, we can ask this particular LLM or AI to make it sad person, or vice versa. Data augmentation for training. So artificially expand your training data set by applying AI friendly transformation, like cropping, flipping, and whatever. Right. So these are the possibilities for the image face detection, face recognition. Okay, now let's see the next one, which is basically image semantic and segmentation. So partition an image into meaningful regions of at pixel level, while semantic segmentation levels are pixels of a class. For example, let's say there's a grass, or let's say there's a table, chair, and whatever. Instance segmentation distinguishes between individual objects of the same class. For example, each separate person. Okay, so semantic and segmentation, instance segmentation. So again, there are some standard packages available where they are already trained with, let's say, 5,000 images or 5,000 items. For example, a dog. So there are, let's say there are 200 types of dogs in worldwide. So each dog, each type of dog, they have taken, let's say, 20 images, and they have trained themselves this particular library, which is um RCNN. Okay, Torch Vision, ResNet 50. Okay, so this is trained with multiple images, and already there is a data set. Based on that, we can pass on some images. For example, this one. Okay, we can pass on this image, and we can say, okay, identify or segment, or segment the person. So first thing what we are going to do is um, draw mask on the image, and draw mask on the image. So first let us run this. Okay, and then we'll see the output, then we will be able to recognize, okay, what we have done. Okay, so if you see in this image, it okay, in the first image it recognized the persons. Okay, and it masked them, right? This is very unique and very easy to recognize and understand. Different persons are there. Same thing for the second image. Okay, so this is a traffic signal crossing, and if you see, almost every person is masked. Of course there are some errors, so that is okay. Let's say 70 to 90%, if we are able to mask or able to at least identify, okay, this particular blob of pixel is a person, uh, we can proceed. Okay, right. So that is about image semantic and segmentation. Right. Next, we have data collection, image object detection. Okay. So we can detect a person or table or something, but now here is specifically an object detection. Okay. And again, this is with Ultralytics. This is again a very good pre-trained um, models where um, we can identify. Okay, let's see this pre-trained YOLO model list. Okay. Okay. So if you see, it can identify various different types of objects. Let's take V8. Okay, so object detection. So let's see, there is a sheet which I want to show you. Yeah. So yeah. Person, bicycle, car, motorcycle, a surfboard, cup, donut, pizza. So how many are there? Let's say 70. So 70, probably there's more than 1,000 also, based on the model and what we choose. So these kind of objects, whether they are, different colors and shapes, so that it is able to identify, which is a pre-trained model. So that is what we can do with the image, from the image, basically image object processing, object detection. Okay, so there are different images. I just run this, and we're able to, we'll see what it identified. There are three images. Okay, so this image, if you see, this is not a cat, but it identified it as 88%, because again there are two objects, so which is might be wrong. This bottom is cat and this is a cat, so this is also wrong. Okay, cat is 52% confidence, cat 0.29, so which is less than 50%, we can just go to ignore it. Okay, this one, so this is dog 90%. Okay, this is a cat 86%, and this is again a cat 77%, which probably is wrong, because this is not a cat, this is a wrong, this is a rat. Okay, now one more thing is, yes, dog 91%, cat 87%, and a teddy bear. So this is not a teddy bear, this is a rat, but then yes, based on assumptions, it identified it as a teddy bear. Okay, and then the percentage again more less than 50, so we can just ignore it. Right, so this way, with this particular model, which is YOLO V8N, we can identify, let's say, hundreds or thousands of objects. Okay, right, so that is also one of the good helping thing for RAG to start the data collection part. Okay, now let's see here. So we have image face detection, semantics, object detection, image classify, utility to convert PMP to PNG, PNG to JPG, and so on. Okay, so right, um, image classifier, again here, again it is going to classify whether it is a dog, which type of dog it is. Okay, so there are different types of dogs. Okay, so image classification and labeling, so automatically assign a category, for example some dog, cat, rat, and animal, a car, to an entire image using pre-trained CNN, convolutional neural networks like ResNet and VGG 16. So these are all again open source, freely available pre-trained models which we can use to, let's say, 70 to 80% identify what are the objects in a particular image based on the context. Okay, so over 1.2 million images across 1,000 categories. Yeah, this is what I wanted to show. So right, ImageNet, DarkNet 19, and BGG Face. So these are again 1.2 million cases. It is already analyzed and pre-trained, which is good to, which is good for practical, lot of practical purposes. Okay, so we have to load the pre-trained model and then assign and then give our sample image to this model and then tentatively identify with a confidence levels. Okay, so let's see. Uh, okay, so these are the images. Dog. Right. So let's take some random example. So first thing is this one. So dog image dog one. Okay, so you see this dog. Okay, so this dog is identified. Okay, obviously identified as dog, but then what? So dog type Visla, which is, let's say, 57%, and then cheese peak, uh, 10%, and then bull mastiff 0.08, so probably 8%. So tentative confidence level is this one. Okay, and then we can take the top two or top three, whichever is having higher percentage. Okay, obviously the image should be clear. So for dog 3, let's see, for dog 3, which is a husky, uh, yes, Siberian husky, if you see 0.16%, um, Malmut, and then Eskimo dog. Yeah. So again, we can see what is the highest percentage of matching, and then we can classify the dog, the object in that person, right? So we can identify and classify it as a cat or a dog, and then again, this one. So if you see this one, this is all combined. So probably it will not take. It will take. It will be confused because it is a combination, and this one. Okay, right. So data collection part, data image classification and labeling we can do, right? Now, data collection dot image. So simply, there are different types of extensions, so TIF, TIW, PNG, JPG, JPEG, and so on, so that we can convert for further processing. Normally we can convert it into, let's say, JPG for faster operation, and in PNG for lossless images comparison or identification. So it has its own trade-offs and benefits. Okay, so this is a sample function which you can reuse. Now we have .epub file. So for books on different platforms, on online platforms, the extension is not PDF, it is .epub. So we can do some operation on the EPUB. We can extract the metadata, read and extract the text, extract the images, modify the metadata, create a EPUB file, or convert some format. So convert it into PDF. Okay, convert it into, let's say, text file, and so on. Right. So I have some sample.epub. There are three EPUBs, and then the image inside the EPUBs. I will just delete this. Okay, and right, so we'll just run this code is also available. By the way, I'm using a library called as ebooklib, okay, which is also freely available. Name OS is not defined. Okay, okay, so first what we have done here is basically extract the metadata, then extract the text and extract the images and modify the metadata and so on. So you can go through this code. So first, the main thing I want to show is, okay, new EPUB, and then book 4 EPUB, and then the text of book 2. The text of book 2 is here. Okay, and extracted images. So again, it has extracted a lot of images. from the ebook file, okay, which probably maybe reusable or maybe useful for some other purpose, right? So um, on the epub file we can do a lot of things. Okay, now let's proceed to the next one. HTML scraping. Okay, scraping is also one of the very important part uh, when we do, you know, processing in the RAG. So there are libraries, beautiful soap, and many other libraries are there. But I'm using the Selenium, which is very easy, and will give a lot of advantages. Okay, so the Selenium part, data scraping, yeah, this one. So in Selenium, again, it's going to be a long discussion, but in Selenium, we can go to different page. We can officially log in with some valid email ID, and we can, navigate to different pages. Extract the, let's say if it is e-commerce page, so we can extract the product title, product cost, and availability ratings, image of the product, and so on. So a lot of things can be identified, uh, and that is it's uh, a very big business of scraping. So I'm doing it with Selenium. Okay, of course we can do with other libraries, but yes. So for example, this is an e-commerce website. Okay, so I'll go to any e-commerce website. I want to know, let's say, what is the title, what is the cost, and what is the image. Okay, I will right click, and I can get the image path. But then now this is I want to do automatically. Okay, and of course I want to go to next page and do the same thing, and I want to go to next page and do the same thing until, let's say, first 5 pages or top 3 pages and so on, or maybe all the pages. So this is possible using Selenium. It's very easy and not that hard. So I'm using um, again XPath and CSS and those things. I have a different video on my channel where I have explained a lot of things for Python plus Selenium, but you can go through it. Okay, so I'm just launching a Chrome programmatically using Python and Selenium. For now, I'm launching it in the invisible mode. Okay, uh, what it will do, it will go to that page. Okay, the URL, this URL, it will go to that URL, and it will get the uh, let's say item text, the e-commerce item text, item price, and the path of the image, and so on. And it will dump it in one text file or CSV file, whichever way we want. Okay, and that we can reuse further for different scraping applications. Okay, right, so let me just run it. So this is okay, anyways, let me just run it. So for now it will run in invisible mode because it is headless. Yeah, headless. Okay, and if you see, it is dumping the product title, the cost, and the view URL of the image. I'll just click on this. So this is the URL of the image, and so on. Okay, again a different e-commerce page, nz.zoro.com. Now in this case, if you see, there is additional pop-up. Okay, if you click on the next page, automatically there is additional pop-up coming. Now this additional pop-up and other elements handling is not probably easily not easily can be handled with the beautiful soap and other things. That's why I'm using the Selenium here. Okay, so it is going to different website. um, Going to next page for, let's say, for 5 to 6 pages, and it will identify the job description and job location. Okay, so uh, job description, the location, and the country or some county. Okay, and so on. So this we can store it in on CSV file, Excel file as per our need, and then we can proceed. Now this is what I think is the cleanest way, because there are a lot of tools which probably are banned, or some of the websites will straight away block those tools, and then maybe your account get locked. So it's better to do the Selenium way. Okay, so that is why I've done it using Selenium way. Okay. uh, right. So here the library is basically the Selenium one I'm using, and there are different applications, different packages and classes, right? So what we can do in the HTML scrapping, e-commerce product monitoring, so we can have product title, price and ratings. uh, we can do a competitor price tracking. Okay. Let it be not a e-commerce one, but let's say uh, some specific, let's say some instrument packages are there, instrument cost is there. Okay, medical instrument, we need to monitor its price on a daily basis. Let's say stock market, so we want to identify the get the price of a particular stock or a index, let's say every 1 minute or something, so that for further analysis. That is why we are using competitor price tracking. Job market, we have seen one example. Stock market, okay, sentiment analysis. So collect thousands of customer reviews and ratings for specific product to analyze the customer sentiment, right? So a lot of things we can do. I have done it with Selenium, which is very simple and easy. You can do it with other libraries. Okay, right. So then we can do the data collection. So HTML scrapping, XML file, MD file, these are all the normal uh, uh, types. So we'll start with the JSON. Yeah. So on a JSON file, or a JSON, what we can do, we can read JSON from a file, write to a file, parse the JSON to a string, convert object to string, rectify the for readability, the JSON dumping, sorting the JSON part as well the alphabetical way, and validating the JSON schema, handle the nested data filter, and modify the JSON. So it's not that great. It's medium to low complexity, but we can just see what we can do. Okay. So yeah, top 10 things, top 9 things which can be done on a JSON or a JSON file. Um, going Okay, MD file and docx file. So XML file. Okay, so XML file, again we can parse the XML, access some elements, root elements or nested elements, searching with XPath, or common XPath and so on. Reading and modifying the text, managing attributes, um, adding elements, removing elements, validating against schema, and writing to a file. So a lot of things we can do on an XML file. We can go through this code, okay, in a bit, but it is not that hard. Okay, we can just run this and see. Fine. So next we have Markdown file. So Markdown file is basically, if you go to GitHub and you see this file, readme. Okay, readme.md. So basically this is the one what we see. It's a readme file. Whatever we see, your image, links and those things, it's a readme file. Technically, if you see, it looks like this. Okay, there is a hash and there is a link and so on, right? So normally it is a .md file. Okay, readme.md file, and this is a markdown file. So what is the need here, what we can do with the markdown file is basically, again, read write, convert to HTML to markdown, uh, front end metadata, extract specific elements, find and replace with regex, table of contents we can identify, and so on. So markdown file, let's say I have a example. I will generate one example. I will save it. This is on the spot HTML, which can be converted to HTML file, actual HTML file. Um, right. So here, okay, there is no markdown file as of now. So let's just learn it once. Okay, there is one error. Access metadata. This one. Title access metadata like a dictionary. Okay, so here load the XML file, which is example.md. So it probably is not available. Okay, now it is available. So right, there are two lines only. This is header and probably this is the body. So what is the error? Title access metadata like a dictionary. You have to identify it as a dictionary. So probably with the double quotes, I think. Okay, so post dot text. Okay, so dot text. Okay, so I will just do the correction in the actual GitLab, GitHub this thing, but it is a front end matter. Okay, right. So then we have a docx file. So again, Microsoft formats document file X, XLS, X file, and so on. Again, the top 10 thing which we can do on the docx file is, create and save docx file, add some heading, insert paragraph. So all those things what we can do from the GUI. Most of the things we can do, or the important or are highly needed things we can do from the Python program. So insert image, extract text, and so on. This is we can do separately. Let me just run it once and run. Okay, probably this method is not available in the current version of this library, current package. No such file as image.png. Okay, so it didn't find the file, which is docx file. So I have to give image file so that it will be appended in the image file. So there is an image data img, and let's say this one ppl1.jpg. Okay, so this image I want to insert. Okay, so existing docx. Okay, so this file is created here, my new file, right? So this is new file. Okay, now moving on, XLS file. XLS file again, very highly needed file type where we can extract a lot of data. So again, the typical top 10 things is reading, writing Excel file, managing multiple sheets, cell level editing, formatting, styling, filtering, sorting, aggregate data, creating pivot tables, inserting formula, and adding charts and images. So there is a data Excel file and there is a sheet one. Okay, so read df1 and then we can do further processing. Write to an Excel file. So read Excel file and dump it into a new file. Multiple sheets. Okay, we can go to sheet 1, sheet 2, sheet 3, and we can extract uh, some information, or we can create additional sheet. Let's say the title of the sheet is marketing and so on. Like there's one more way to how to give the title and so on. Cell level editing, so yes, we can open the XLS as a workbook. Then we can set the active worksheet, and then on that worksheet, cell A1, the value we want to change it to new, some new value. Okay. Then formatting and styling, so we can do let's say the header like this, three headers, paint the header and then the values. Okay, so formatting and styling, um, right? Add data, yeah, we have seen. Style the status, yes, we can, whatever cell or group of cells we have, we can give some color, font color, alignment, left, right, okay, the font style, thin, and some color, and so on, and then save it. Okay, no such file, data.xlsx. So okay, so I will just create one file, data, okay, open it, add some content, save it, run it again. Okay, so again, need to close this and now run it. Okay, so no such file, data.xlsx, because that file is basically should be in this folder. Okay, so we have the data file and then run it. Okay, so sales worksheet, there should be a worksheet called as sales. Close and run it. Worksheet sheet 1 is not found. Okay, so there's a new error. So we want to have a worksheet called as a sheet 1. Sheet 1, again some text here and there. Run it. Okay, so some new error and so on. Sheet 2. Okay, we should have a sheet 2 also. Yes, there's a sheet 2, right? So let's run it again. So new error. Sales status. Okay, so there is a worksheet available, but it has to have certain kind of data, some table expecting, right? So the basic thing is we can do this kind of operation on the XLSX file. Okay, then we have the PDF file. So we will see PDF file in a bit. So we have seen doc, XLSX, PDF, CSV, text, and okay, so PDF file. So one of the major source of information in different rags practically is coming from PDF, and we will see this in a bit detailed way. So what are the operations we can do on PDF? So obviously read object and read a page or a set of pages, read entire PDF. We can rotate our individual page also. Then merge two different PDFs, split a PDF, let's say it has 10 pages, I want to split from page number 3 to 9 and so on. We can add a watermark, we can extract a table from a PDF. Okay, then we can do a website which is an HTML format, so we can convert it into a PDF format. Then we can compress the PDF. Yes, for certain requirements we need to compress the PDF. We can extract the images from PDF and save it in a separate folder, then apply OCR and those things. Um, Generate some dynamic reports from scratch using report lib. So this report lab package is very good, uh, having a very good reputation for medical applications and so on. Transform PDF to images and vice versa. encrypt, password protect the PDF and then decrypt with a known password. Extract images, yes. Chunking data and extracting with metadata to arrange llama index. Okay, we will see this in detail. So there are certain PDFs available. Okay, so PDF path. Okay, so I have taken three PDF: Lenskart terms and conditions, Zomato terms and conditions, and table one. Okay, so we'll see this data, PDF, Lenskart, then Zomato, then table. So uh, Lenskart some terms and conditions. Okay, then Zomato, terms and conditions, and there is a PDF where there is a table. Okay, so we'll see one by one. So reading a PDF, reading entire PDF and just print the number of pages in the PDF. Okay, simple. So there are 12 pages in the PDF path, which is Lenskart PDF. Okay, so Lenskart PDF, Lenskart 12 pages, right? Then print the page content. Okay, we can print the page content page by page. We can just append it in one string and then print it. Okay, now rotate the page. Okay, so let's say I want to rotate the first page by 90 degree. Okay, you can rotate it multiple of 90 degree. Let's say 90, 180, 270, 360, and so on. So we can do that. Then merge different PDFs. So we can merge the PDF also. So let's just run it once. So PDF, right? So this is a Lenskart new, where if you see the first page is rotated. Okay, it is rotated. Then Lenskart merged. So different Lenskart and Zomato is merged here. Then split PDF. Okay, a straightforward split PDF from page number 1 to 2. And then add watermark. So we'll see this. So splitting the PDF, right? So only two pages are there. Okay, and then Zomato watermark. So if you see there is a watermark, this additional image I've used it. I want it to be used as a watermark. So I, yes, that is what I've used. Okay, yes. So we can add a watermark. Then extract the table from PDF. Okay, so we can extract the tables also. So there's a PDF 4. PDF table, yes, this is the one. This is the one which is having tables. So we want to extract it as a table. Okay, so that is possible. Table settings, and then PDF plumber is one package which will give us this utility. Right, so detected uh, 47 rows and 9 columns. So 47 rows, okay, and 9 columns. So yeah, there are 9 columns, right? So this is the PDF extract this thing. Future scope PDF table to CSV. Convert the PDF table to CSV file directly or Excel file directly. Right, now HTML to PDF. Okay, so what I want is I want to go to this page. Okay, or for that matter any page. Okay, and I want to save this entire thing as a PDF. Okay, so yeah, this is the page, right? So entire thing. Okay, if you see there's a bit of a scrolling here. So I want to save this thing as a PDF. So what I can do is go to this website. Now I'm using a different library apart from Selenium, which is a Playwright library. Just launching the Chrome, and then going to URL and getting the HTML part and saving it as a PDF. Okay, as simple as that. So it will be saved as HTML to PDF. Okay, so let's just run it. Okay, HTML to PDF. Right, so if you see this page and this page, so pretty much it is saving a lot of things with CSS and everything in a PDF file. Okay, there is some additional text coming, which is this one. That is okay. Okay, additional text is coming. That is okay. Right. So right, then compress PDF. Okay, so we can compress the PDF, extract the images, generate dynamic reports using report lab and so on, which is a not a generic example. Maybe you can Google it. Right, now encrypt and decrypt. Yes, I want to show this example. Okay, so a lot of cases we need to do a password protection or unlock the protected PDF file, so that we can. So that is what is done using encrypt and decrypt. Okay, so that can also be run. Okay, file encrypted and file de-encrypted. Okay, right. So if you see this one, Zomato encrypted. So if you ask for a password, I will simply say something. That won't work because it's the invalid password, and this is the extracted image. Okay, extracted PDF. Right. So that is what it will do. Right now, uh, let's run this. PyMU4 PyMU PDF4 LLM. Okay, this is again a little futuristic for now. It is for LLM we can do some chunking and data indexing and so on, so that can be done using PyMU PDF4 LLM package or library. So there's a function called as toMarkdown, where we can specify um, different formats or different folders, okay, and where we want to store the images and so on. Little advanced part, which is chunking data and extracting it with metadata, which probably we can skip for now. This chunking thing we will see in a separate video. Okay, arrange llama index, again this is an indexing part. What it is and how it can be done, so that also we'll see in the next part, but for now I will just run it and see that things are working as expected. Extracted images. Yes, it has extracted the image automatically. Right. Okay. So this is still acceptable. Uh, Again, the last one is the CSV. Right. So on CSV we can read as a list, read as a dictionary, writing rows and reading it into data frame, pandas, filtering, selecting columns, aggregating, many other things. Okay, saving. So I'll not go much into detail because it is self-explanatory. And the normal text files, we can read, write, and play with the text file and so on. So this is all about the data collection, the related items for RAG. I hope this is very useful for your lifetime usage. Right. So sources of information, for example, additional things apart from what we have seen. So ELK or Splunk logs, then some traces of correlation IDs, infrastructure metrics, CPU usage, memory, API documentation. Yes, Swagger, service discovery. Yes, database schema. We have seen the database schema. documentary for documentation, confluence, git commit history, CI/CD. Yeah. So again, we can increase it to 100 parameters, what we want. But then, we need to see what are the major types. So that is, yes, that is all about it. So if you like this video and this channel, please like, share, and subscribe. Thank you.